question 11. Alright, this is question 11a. Alright, it says the matrix M is defined as determine the value of P for which the matrix M does not have an inverse. Determine the value of P for which the matrix M does not have an inverse. A matrix does not have an inverse if it's a if it is a singular matrix. If a matrix is a singular matrix, it does not have an inverse. In other words, if its determinant is equal to 0, it does not have an inverse. So let us find the determinant of M. The determinant of M would be 7 times minus 2 minus 1 minus 2 times P. Now, so this is equal to minus 7 minus 2P. Now, in order for M not to have an inverse, its determinant must be equal to 0. So what we need is the value of P that is going to cause M not to have an inverse. But remember, M does not have an inverse when its determinant is equal to 0. So let's put this determinant equal to 0. Minus 7 minus 2P is equal to 0. Remember, when the determinant is 0, the matrix does not have an inverse. 2P goes over and become what? Negative 2P goes over and become what? Minus 7 is equal to 2P. Divide both sides by 2. P is equal to minus 7 over 2. Ladies and gentlemen, when P is minus 7 over 2, the matrix M does not have an inverse. When P is minus 7 over 2, the matrix M does not have an inverse. B says 4x minus 2y is equal to 0. We're also told that 2x plus 3y, 2x plus 3y is equal to 4. We're to express the equations in the form AX is equal to B, where AX and B are matrices. In other words, we need to write our simultaneous equations write them as a matrix equation. It's not difficult. We're going to take the coefficients of x and y. The coefficients would be 4, 2. Do you agree?
Yes, sir.
Minus 2, 3. Multiplied by x, y is equal to 0, 4. Now this is in the form AX is equal to B. That's what we're asked to do.
I don't know.
But you know the weirdest thing? He didn't ask you to do anything else, you know? All he said was what? Write it in that form. The question, that part of the question is finished. He did not say solve it. He didn't say find out what x is. All he said is write it in this form. Did we do it?
Yes, sir.
That is done. 2 marks of this, 2 marks of that. Let's move on to the vector question now. The vector question is the C part of the question. There's a diagram. This is the y-axis. This is the point P. P is the point 2, 5. Q is the point 8, 2. Q is out here, so, and it is the point 8, 2. This is Q, and Q is the point 8, 2. This is the x-axis. Alright? So this vector here would be a position vector, and this vector here would be a position vector. A position vector is a vector that is tied to the origin. It says in the diagram below, the coordinates of P and Q are 2, 4, and 8, 2 respectively. the line segment joining the origin to the points P may be written as that. Okay, fine. So what term is used to describe we're asked, what term is used to describe OP with an arrow over it? What term is used to describe that? You know, I said it already. What term is used to describe that? I said it already. Huh? OP is a position vector. Yes. The term that is used to describe it is a position vector. OP, and you all should know that. OP is a position vector. What is a position vector? A vector that is tied to the origin. This says, write each of the following in the form AB. A, O, P. And we need to write it in the form AB. Alright, ladies and gentlemen, please note, this is something I told you about a position vector. For a position vector, the coordinate and the vector has the same value. You remember that?
Yes, sir.
So if this is the point 2, 5, it means that OP is the position vector 2, 5. That's that. That's all you have to do. That is 1 mark. OQ, B, OQ. Ladies and gentlemen.
Sir, 2, 5 or 2, 4?
2, 4. 2, 4?
Yes.
Sorry about that. So this should be 4. And this should be 4. Now, PQ is the point 8, 2. It means that OQ is the vector 8, 2. For a position vector, the coordinate and the vector have the same value. The coordinates and the vector have the same value. Next we need what? C. C is PQ. C is PQ. For PQ, I'm going to use the triangle law of vectors. Triangle law of vectors says that PQ is equal to PO plus OQ. You start at P and end at what? And the next letter goes in the middle. What is OP?
2, 4.
What is PO?
Minus 2, minus 4.
This is minus 2, minus 4. Plus OQ, what is OQ?
8.
2. Yes. This is minus 2 plus 8, minus 4 plus 2. This is 6 minus 2. PQ is the vector 6 minus 2. How could you? How could you? Given that, I listen. Given that OP is equal to RQ, OP is equal to RQ. Determine the coordinates of R. Given that OP is equal to RQ, determine the coordinates of R. OP is equal to RQ.
So 11 a 2, 4.
I'm coming. This is R. We're told that OP and RQ are equal. We're told that OP and RQ are the same vectors. We're asked to determine the coordinates of R. Here's what we know. Remember we said that the position vector and the coordinate have the same value. So if someone asks me to find the coordinate, I can easily find the position vector, because the position vector and the coordinate will have the same value. So let's find the position vector OR. Ladies and gentlemen, OR using the triangle law of vectors. OR is equal to OR would be equal to, so OR would be OQ plus what? QR. So this would be OQ plus QR.
What?
Triangle of vectors. OR would be equal to OQ plus what? QR. But remember, we were told that RQ is the same as what? Remember, RQ is the same as what? OP, don't it? Fine. Now, what is OQ? What is OQ?
8-2.
So this is 8-2. Now, what is RQ? RQ is what? The same as OP, which is what?
2-4.
So RQ is what? 2-4. Therefore, RQ is what? 2-4. So what is QR?
-4.
This is plus, -2, -4. This is 8. Positive times and negatives are negative. And this is what? 2 minus 4. This is 6 minus 2. Ladies and gentlemen, this point here, therefore, the point R, therefore, R is the point 6 minus 2. R is the point 6 minus 2. Why? The coordinate and the position vector have the same value. State what type of quadrilateral, state the type of quadrilateral formed by P, Q, R, and O. Justify your answer. So here's what they're asking you. What type of quadrilateral is this? Are you listening? They're asking you, what type of quadrilateral is this? You tell me, and you must justify your answer. What did they tell you about this side and this side? What did they say about OQ, OP, and RQ? They're what? They're equal what? Vectors. If they are equal vectors, it means that the length of this side and length of this side is the same. Two vectors are equal if they have the same what? Magnitude and the same what? Direction. If they have the same magnitude, the length of the line representing them are the same. So the length of this side of the quadrilateral and the length of this side of the quadrilateral is the same. If the two vectors are equal, they are also what? Parallel. So opposite sides of this quadrilateral are equal and they are what? Parallel. What type of quadrilateral it is? Ladies and gentlemen, P, Q, R, S is a parallelogram.
A parallelogram is a quadrilateral?
Don't talk too loud, people can hear you. Opposite. Sorry. RQ and OP are equal vectors. Therefore, RQ and OP are equal in length and are parallel. A quadrilateral, if opposite sides of a quadrilateral are equal and parallel, that quadrilateral is a parallelogram. Alright, I'm convinced that you won't have to write so much. I'm convinced you won't have to write so much. Alright, so But one thing you have to tell it is that what? It is a parallelogram. And you have to simply tell it that opposite sides are what? Equal and parallel. Opposite sides are equal and parallel.